This is section 14.5, and we call this section, well, we say that it's about related rates, and they're word problems. So we have about 7 problems that we need to do. And here are the steps that I've come up with for you. Number 1, draw a picture if that's going to help us. Write down your given info. What are you given? 3, write what you're asked to find, which is usually a rate. Remember that derivatives are rates. Write a formula or equation that relates your variables. Use implicit differentiation to solve and evaluate. Now, we just did implicit differentiation where we were doing y with respect to x. In related rates, everything will be in relation to t. It will be a derivative with respect to time. So every variable will get a dt added on. So you'll see what I mean when we go to work the problems. Let's go ahead and do that. All right, number 1 says assume x and y are functions of t. Remember we talked about functions of time. Evaluate dy dt for this expression, and they give you what dx dt is and what x is and what y is. So we're going to go through the process and then we'll be plugging in these things and solving for only dy dt. So when we start, I wrote the problem just as it is, and we have to recognize this is a product. So it's 3x times the derivative of y, which would be 1 dy dt, plus y times the derivative of 3x, which would be 3 dx dt, minus derivative of this is 2 dx dt, plus 3 times 6, 18 y squared dy dt, and the derivative of negative 36 is 0. Now in the next line, we're just kind of cleaning it up. I moved this 3 to the front of the 3y, in front of the y. We've got that, we've got that. So that's all I did there. Then I've got where I can plug in. I want to put x is 6, everywhere there's an x. Everywhere there's a y, I'm going to put negative 1, and where there's a dx dt, I'll put negative 18. So I've got 3 times 6 dy dt, which is what we're solving for, plus 3 times y times dx dt, minus 2 times dx dt, plus 18 times negative 1 squared dy dt. So I substituted in the red parts from what I was given in the problem. So now I have 18 dy dt plus 54 plus 36 plus 18 dy dt equals 0. I'm going to combine the dy dt's, so I have 36 of those, and 54 and 36 is 90. I'm going to subtract that to the other side. Then I'll divide by the 36, so dy dt is this. I can divide 18 into both of those and reduce that to negative 5 halves. So dy dt is negative 5 over 2. So we did all the derivative stuff, then we plugged in the things that we were given, and then we solved for dy dt. So that would be number 1. Number 2. All right, number 2 says find the rate of change of total revenue, cost, and profit with respect to time. Assume that Rx and C of x are in dollars. So we're given R of x here, C of x here, and we're evaluating it when x is 30 and dx dt is 20. All right, so first take your revenue function. That was given here. We're going to find the rate of change of revenue. That's dr dt. So that's what we're solving for. Equals 55. Now we don't have that x anymore, so it's 55 dx dt minus 2 times 0.5 is 1 x dx dt. So then we're going to plug in these values we were given. So 55 times 20, because that was the blue, minus 30 times 20, and that all equals $500. So the rate of change of total revenue is $500 per day. We'll do the same thing with the cost function. Here is the cost function. So taking the derivative of C is dc dt equals 2x dx dt. That goes to 0. We'll plug in the 20 that goes in for dx dt. That equals 40. That $40 goes here. The rate of change of total profit, we can just take our revenue change and subtract our cost change, and we get 460. That should be what goes right here. All right, that should be number 2. All right, number 3, the brain mass of a fetus can be estimated using the total mass of the fetus by the function B is equal to 0.22 times the total mass raised to the 0.87, where M is the mass of the fetus, so the whole fetus, and B is the brain mass. Suppose the brain mass of a 22-gram fetus is changing at a rate of 0.21 grams per day. Use that to estimate the rate of change of the total mass, or dm dt. So we are given that B equals 0.22 m to the 0.87. That was given right there. Now if I take the derivative of that, I've got dB dt equals, multiply 0.87 times 0.22, you get this, m to the, when you take 1 away from 0.87, you get negative 0.13, and it's dm dt. Now, we are given that this brain mass of a 22-gram fetus is changing at a rate of 0.21. So we're going to substitute for the dB dt, we're going to put 0.21 equals 0.1914, and the mass that they're asking us to check on is a 22-gram fetus. So we put 22 here to the negative 0.13 dm dt. And we are solving for the dm dt. That's what we're trying to get, and we've got everything else. So I did this calculation on your calculator, and I would start by doing 22 raised to the negative 0.13, and then multiply that by 0.1914. So you get this value. Then we're going to divide this into 0.21, and we get this, and it wants 5 decimal places, so 1.63981. That's 0.21 divided by this number, okay? And we wrote down what we were given here. Given dB dt is 0.21, find dm dt when m is 22. All right, let's go look at number 4. Suppose the average daily metabolic rate for certain types of animals can be expressed as a function of mass by R equals 143.8 m raised to the 0.75. M is the mass of the animal and R is the metabolic rate. A part, if the mass of an animal is changing at a rate of dm dt, find dr dt. So this part, we would go here, we have R equals, and this is what we were given right here, dr dt, we're taking the derivative, equals, multiply 0.75 times this number, take 1 away, so you've got 107.85 m to the negative 0.75 dm dt. And so I believe that it wants you to put this part here and put dm dt, or choose dm dt here. So that's the answer to the first part. Then B, determine dr dt for a 70 kilogram animal that's gaining mass at a rate of 2 kilograms per day. So we've got this. We're going to plug in 70, that's the mass of the animal, and then it's changing, where did it say that? And gaining mass at a rate of 2 kilograms. So dm dt is 2. So we're plugging in 70 here and 2 here. You do this calculation and you get 74.572. That's what's going to go here. All right, so we do have those answers. Let me move this out of the way so I can, so this is that first piece, and dmdt was what we chose there, and then the last answer, the drdt, is here. So we had those. All right, let's go to number 5. Number 5 is a ladder problem. A 20-foot ladder is leaning against a building. Great picture, right? If the bottom of the ladder is sliding along the pavement directly away from the building at 1 foot per second, how fast is the top of the ladder moving down when the foot of the ladder is 4 feet from the wall? So let's kind of put that into what we're given. If we think of this as a right triangle, and this is X and this is Y, and here's the ladder is 20. So we're given that this is changing at a rate of 1. So it's moving away at a rate of 1 foot per second. So given that, find dy dt. We want to say how fast is this changing when X is 4? So what do we know? We've got to come up with something that relates the variables. Well, since this is a right triangle, x squared plus y squared equals 20 squared. Then we're going to take the derivative of that whole thing because we're talking about a rate. 2x dx dt plus 2y dy dt equals 0. And then I'm going to subtract the 2x dx dt dx dt over here. I'm going to divide by 2y. So dy dt equals this. These 2's are going to cancel out, and I've got negative x dx dt over y. So I do need to know the y when x is 4, because I know the dx dt, that's 1. So back up here, if x were 4 squared plus y squared equals 20 squared. That's 16 plus y squared equals 400. Subtract the 16 over, y squared is 384. Take the square root of that, you get 19.596. So over here, I'm going to plug in what I know. I've got negative 4, because that's negative's part of the formula. Plug in x is 4. dx dt is 1. We were given that. We solved for y. Now, if you do this calculation on your calculator, you get negative 0.204. Now, we need to remember something. If I were doing this on paper and just asking the question, this is what we would get. But in the way the answer's worded, it says it's moving down at a rate of. So the moving down took care of the negative. So in here, we're just going to put the positive value 0.204. All right, so let me try to write that. Okay, so I was doing that with my mouse. It's not as cool, but we don't have the negative there because we took care of it with that word down. All right, number 6. A rock is thrown into a still pond. The circular ripples move out from the point of impact so that the radius of the circle formed by a ripple is increasing at the rate of 2 feet per minute. Find the rate at which the area is changing at the very instant that the radius is 7. All right, so we are given that the radius is changing at a rate of 2. So that's dr dt is 2. Find the rate from the area. So that's dA dt when r is 7. So we've written down all our information. Now the formula about the circle, the area of a circle is pi r squared. So let's take the derivative here. dA dt, that's the derivative of that. Remember, pi is a number, so 2 pi r dr dt. Now we can plug in everything. We're trying to find this. We're going to let 7 be r, and our dr dt is 2. So we got 2 pi times 7 times 2. That's 28 pi. And we'll probably use the pi key on our calculator when we're plugging that in. And so it does say, find the rate, so that's 87.965. There we go. Number 7, an ice cube that is 9 centimeters on each side, so it's a perfect cube, is melting at a rate of 5 centimeters cubed per minute. How fast is the length of the side decreasing? At the moment when the cube is 9 centimeters on each side, the side length is decreasing. So again, we're taking that word means we're going down. So when we get a negative in our answer, we're not going to put the negative here. We're going to put the positive. So if you think that the volume of a cube is each side cubed, because they're all the same side. So if we say V is S cubed, so we take the derivative, dV dt equals, bring 3 to the front, 3s squared ds dt. Now we're going to plug in. So dV dt was given, that was 5. So we're going to, and it's melting, so it's going to be a negative 5 equals 3. The side is 9 squared, and we're looking for ds dt. So this becomes 243. We'll divide that into a negative 5. We get negative 0.021 equals ds dt, but we're going to put the positive value up here. So I put that up there. We do get a negative, but the decreasing at a rate of, the decreasing took care of the negative. So I think that will take care of our related rate problems. Hopefully you will be good with those.